Okay, today we're going to be talking about the graph of a function and its inverse. So, let us first of all consider some function. Let's consider a function defined by f of x equal to 2x plus 1 for x belonging to all real numbers with the domain minus 4 less than or equal to x less than or equal to 2. So let's think about when the values of f of x at the limits of the domain. So f of minus 4 is going to be minus 7 and f of 2 will be 5. Now we've already said this is the domain, so we'll write that down. Domain is minus 4 less than or greater than x less than or greater than 2, and the range will be these values here. It will be minus 7 less than or greater than is less than or equal to f of x is less than or equal to 5. Now we can, I'm going to do the inverse on this side. So if we were to go through the steps to find the inverse of this, the inverse would be equal to x minus 2, x minus 1 over 2. Now the domain of the inverse would be the same as the range, so minus 7 less than or equal to x is less than or equal to 5, and the range of the inverse is same as the domain of the function. There we go. Now let's sketch, first of all let's sketch f of x. So f of x, when it's f is minus 4, x is minus 7. It's down here. So that's going to be minus 4, 7. And for f is 2, f of x is 5. That's 2, oops, 5. And then we're going to get this kind of line here. Now, for the domain, for the inverse, we have when f, the domain here is, so when f is going to be, the inverse of f of minus 7 is going to be equal to minus 4. And when for the domain, the other end of the domain, f of 5, we're going to have it equal to 2. So let's sketch these on. So minus 7 is going to be down. Minus 7 is going to be over here, a bit longer. Minus 7 minus 4, so it's going to be down here somewhere. This is minus 7 minus 4, and then we're going to have over here 5, 2. Go through here. So what this shows us is the representation. That's the representation of f the inverse of the function on the same graph shows us that f and the inverse are reflections of each other in the line y equals x. So if we were to take y equals x, here's y equals x. This is a line of reflection for the function and its inverse. And this is true. This is true for all one-to-one functions. So every time you've got a one-to-one function, you will find the function and its inverse are reflections of through this line y equals x. So I'm just going to write that down. The graphs of f and its inverse are reflections of each other in the line y equals x. This is important to remember. This is because f of the inverse of x, so if you take the composite of the function and its inverse equals x, which is the same as if you take the composite of the inverse and the function, that will also equal x. When a function f is self-inverse, so that's when f of x equals the inverse, the graph f will be symmetrical about the line y equals x. So let's look at an example. So let's consider f of x equals x minus 1 squared minus 2 for x belonging to the real numbers, and we're going to look at it in the section 1 less than or equal to x less than or equal to 4. So this is our domain. Now, on the same axis, draw f and its inverse. So let's consider this. Let's consider y equals x minus 1 all squared minus 2. Now we're going to look at this bit here. So when you get a function and you've got a part of it which is a quadratic, a squared part, this part here can never be less than 0 because it is squared. So this minimum value it can have is when x equals 1, which is the limits of our domain. And when x equals 1, y is going to be minus 2. Now let's look what is it when x equals 4, so the other end of our domain. Y will be 7. Now, the function is 1-to-1, so the inverse exists. So we know a 1-to-1 function, the inverse will be a reflection through y equals 0. So we don't need to go and find the inverse of this. So let's first of all draw a sketch of the function. So we know the minimum value is going to be at down here at 1 minus 2. And the maximum value is going to be at 4, 7. It's up here. And it's going to kind of curve a wee bit like a hockey stick. Now we're going to draw in here, we're going to do a dashed line for y equals x. Now the reflection, we're going to, for this point here, is going to be reflected at minus 2, 1. So it's going to be minus 2, 1. So the coordinates flip. What was x is now y, what was y is now x. And then for this one it's going to be 7, let me just be a bit longer. We'll see it's a 7 and 4. So that's going to be 7, it's about 4 here. It's about here. So that's going to go it's a pretty bad, that'll be a minute, let's try and draw that a bit better. It should be I've made that too much. It's, yeah. Let me just, I'm going to redraw this because it's terrible. Right, just, right. Let's just draw this again. Okay. So we've got 1 minus 2. We want to have 1, 2, 3, 4 here, 5, 6, 7, be about here, and we want to have this point is going to be 1 minus 2 about here, and then 1's going to be about here, so that'll be here, and I think we need to make this a bit higher up here, minus 2, so let's try about here, and then for, we're going to draw our y equals x line, and then we've got 4, and I'm going to make 4 move in a bit. Here. 7's over there, and 7's up there, so 4. This is going to kind of go up that. And like that. And so that one here will be 7, 4, and this is 4, 7, and this is 1 minus 2, and this is minus 2, 1. So that's a wee bit better. Yeah, so the important point is when you're sketching these, you make it look like it's a reflection. So be careful with how you do it. Try and be a wee bit accurate with your sketching, because my first attempt was awful. Right, let's do another one. So for this function, x is mapped onto 2x plus 7 over x minus 2 for x belonging to all real numbers, but x not equal to 2. Find an expression, find f of minus x, find the inverse. So, first step is to make y equal to 2x plus 7 over x minus 2. And then we're going to interchange x and y. So x now is going to be 2y plus 7, y minus 2. And we're now going to rearrange it. So we'll have x, 2y, multiply both sides by 2y minus 2, sorry. And then we'll have 2y plus 7. Let's multiply this out. Minus 2x, and let's bring all the y's over to this side and all the x's over to the other side. So we'll have x, y, minus 2y equal to 7 plus 2x. Let's take the y's out here, so we now have x minus 2. 7 plus 2y, and now we'll have y equals 7 plus 2x over x minus 2. Now, what does this show? So hence the inverse is equal to 7 plus 2y, 7 plus 2x, x minus 2. But this is the same as our function. Oh dear me. This is the same as our function. So this is a self-inverse. So the second part of the question is state what this tells us about the symmetry of y equals f of x. So because f inverse is the same as a function, the function is a self-inverse, therefore the graph y equals f of x must be symmetrical about the line y equals x. So I hope that helps.